In this tutorial, we will create a simple piping system and calculate the pressure drop and outlet pressure. First, we will add two battery limit blocks from the model palette. You can open the model palette by clicking the corresponding button in the View tab or by pressing the F4 shortcut key. To add a battery limit, select the required symbol from the Battery Limit tab in the model palette, and then click on the flowsheet. You can also drag and drop the symbol directly onto the flowsheet. Next, we will connect the two battery limit blocks with a pipe. To create a pipe for a Newtonian fluid, make sure that the Newtonian fluid checkbox is selected. Then, click the pipe button to activate connection mode. When you move the mouse over a block on the flowsheet, the available connection points will appear. Click a connection point on the first block to define the starting point, and then click a connection point on the second block to define the endpoint. Next, we need to specify either the starting pressure condition or the endpoint pressure condition. The available pressure inputs are determined based on the degree of freedom of the piping network. In this example, we will specify the starting pressure by entering the pressure condition in the upstream battery limit. The battery limit window includes three pressure fields: inlet pressure, outlet pressure, and pressure drop. The inlet pressure represents the pressure entering the battery limit block. The pressure drop represents any pressure loss occurring within the battery limit segment itself. Normally, the pressure drop across a battery limit is set to 0. Therefore, the inlet and outlet pressures of the battery limit will be the same. If no elevation is specified, PES assumes an elevation of 0 meters. Since the upstream pressure has already been specified, the inlet pressure of the downstream battery limit will be calculated automatically. As you can see, the inlet pressure field of the downstream battery limit is read-only. You only need to enter the pressure drop across the downstream battery limit, which is also normally set to 0. When a block satisfies the minimum input requirements for calculation, its color changes. The message box at the bottom of the block window will also display ready to run. The next step is to define the pipe properties. In this simple example, the fluid is in the liquid phase, and we will enter only the basic calculation conditions. In the Piping tab, you can define the pipe specifications. You can select the pipe class and pipe size that were previously configured in the Pipe Sets tab. In the Pipe Sets tab, you can manage pipe classes, add pipe sizes, and modify the pipe schedule and roughness for each pipe class. You can also edit the pipe schedule table. For this example, we will manually enter a pipe length of 100 meters. Once all blocks and pipes satisfy the required calculation conditions, the Run button becomes active. This means that all required degrees of freedom have been satisfied and the piping network is ready for calculation. Click the Run button to start the simulation. When the calculation is complete, the colors of the blocks and pipes will change according to their run status. Dark blue indicates that the calculation has converged successfully. The calculation results can be viewed in each block or pipe window. You can also display pressure labels on the flowsheet. These labels allow you to quickly identify which pressure values have been specified and which values have been calculated. You can also generate result tables directly on the flowsheet by clicking the Table button in the Flowsheet tab. You can select which block types should display tables and manage the information shown in each table through Table settings. In addition, when you move the mouse over a block or pipe, a table containing the selected information will appear according to your table settings. If elevation needs to be considered, enter the elevation for each block. The elevation change across the pipe is calculated automatically from the difference between the upstream and downstream block elevations. Therefore, you do not need to manually enter the elevation change for each pipe. You can add elevation-related pipe results to the table, including the pressure drop due to gravity and the net elevation change. You can also add block-related information, such as the block elevation, to the table. Thank you for watching this tutorial.